Hello friends, welcome back. Hearty welcome to you. In the last session we have seen some examples on how to solve the quadratic equations by using factorization. In this session let's try to understand an interesting concept called completing the squares method. Now what is the meaning of completing the squares method? To understand that we'll take a simple example. Let us say, suppose I want to find out the roots of the quadratic equation x square minus 8x plus 15 equal to 0. So what I will do now is I will say that x square minus 8x equal to minus 15. Now if you observe the left hand side, we have x whole square minus 2 into 4 into x is equal to minus 15. Now what is this actually? If you see here, we are having a part of a minus b whole square. We have a square minus 2ab, but b square is missing. So if we add b square on both the sides, then we will complete this as a square. You will make it as a minus b whole square or a plus b whole square as needed. That is what is nothing but completing the squares. It's very simple. So let's try to finish this. We will write it as x square minus 2 into 4 into x. When you compare them, 2 is okay. A is x. So a is x gone. Left out is b equal to 4. So I know b is 4, so that I can complete the whole square. So I'll write it as 4 square minus 4 square equal to minus 15. Now if you observe this whole thing can be written as x minus 4 whole square is equal to minus 15 plus 16. Or I can write it as x minus 4 whole square equal to 1, or I can say x minus 4 equal to plus or minus 1, because if it is minus 1 also, when you square it will become 1 only. So we have two answers now. X equal to 1 with plus 4 plus 1, which is equal to 5. The other one is 4 minus 1, which is equal to 3. So you have to remember, one time we take with plus 1 and we take with minus 1 on the other time. So one is 4 plus 1 and the other one is 4 minus 1. So we have 5 comma 3 are the roots of the quadratic equation. Same thing you can apply by splitting the middle term also. It will be nothing but x minus 5 into x minus 3 equal to 0, or can I say x equal to 5 or 3. So this method of taking a square minus 2ab and padding up with b square and subtracting, so that you can convert the a square minus 2ab into a minus b whole square by adding the b square term, is called the completing the square method. Now let's try to understand this pictorially so that it will be very easy to understand. Then we will go through couple of examples. Let us say we have to complete the square for x square plus 8x. Now x square is x by x is a square, and 8x is a rectangle with breadth as 8 and length equal to x. Okay, now we have this. So what we have done, the next step, if you remember, we made it as x square plus 2ab x square plus 2 into 4 into x, that means 2 4x. So I will take this part is 1 4x, another part is another 4x. Actually it's a 4 and 4 because we already have x there, so that this is 4 dividing 8 into 2 equal parts, 4 and 4, and we have x here. So this is nothing but x square plus 1 4x plus another 4x, or can I write it as x square plus 4x plus 4x, so that you are clear. I'll write it down. x square plus 4x plus 4x. Now, the same thing I can rearrange them in such a way that I can see what is the term which is missing to make it as a perfect square. Let's go to the next step. Now we have rearranged the 1 4x to the bottom, so that we have this is x square, x into x, and this is 4x, and this is another 4x. So we have x square plus 8x. Now you want to make it a whole square, you know that this particular piece is missing. If I get that particular piece, or I add that piece, which is nothing but b square term, if I add it, then it become complete, it will become complete square, because you can see it's a square now, x plus 4 whole square, because this is x and this is 4, it becomes x plus 4 whole square. So how I can write that in other way? Let us see. Which we can write it as x square 4x 4x, this is 4 square, and subtracting with 4 square. So this is nothing but x plus 4 whole square minus 4 square. So this is called completing the squares. If you have been given x square plus 8x, writing it as x plus 4 whole square minus 4 square is called completing the squares. So let's try to understand this again. Suppose we have been given x square plus 8x. Now we know that x square is a square and x square plus 8x is a rectangle. We want to make this as a square. So we are dividing 8x into two equal parts. That's nothing but 2ab term. So ab is 4x. AB is 4x. Now we are rearranging that to the bottom. So we can see now, to make it as x plus 4 whole square, I need this part to be filled up. This part to be filled up. Now I don't have that part, so I will add it up. Then afterwards I will subtract it. This is called completing the squares method. So what you do algebraically is very simple. You just take the coefficient of the 2ab term and divide by 2. That will give you the b. Because if you are having 8x, 8x is equal to 2ab, you know always a is x. We will see that we always make sure that a is x only. Then 2 will go 4 times. That means b will be nothing but equal to 4. Or can I say directly, what is the quotient of 2ab term or x term? Divide that by 2. So b equal to 4. Now let's look at one more example. Now why we have taken this example is, we see that the quotient of x square is not 1. There are two ways of solving this problem. One is to make sure that a square becomes a perfect square. 5x square is root 5x whole square, which is complicated. Now you can multiply with 5 and make it 5 throughout the equation and make it as 25x square. But I always prefer to keep the coefficient as 1, so I will divide always with whatever is the quotient. Dividing by 5, I will have x square minus 6 by 5x minus 2 by 5 equal to 0. Now this is what I advise you to do. Whenever you have a coefficient of x square term which is not equal to 1, always divide by that quotient to make it that always a equal to x, so that your b will be nothing but x term by 2. whatever the x term coefficient you have, that divided by 2. Okay, now what is your here quotient? 6 by 5. So b is equal to 6 by 5 into 1 by 2, that is equal to 6 by 10. So we'll write it down. We'll write the next step as x whole square minus 2 into x into 6 by 10 is equal to 2 by 5. Now we see here we have a square minus 2ab. Missing is b square. B square is missing. So let's add b square now. So the next step will be x whole square minus 2 into x into 6 by 10 plus 6 by 10 is actually 3 by 5. So plus 3 by 5 whole square equal to 2 by 5 plus 3 by 5 whole square. What we have done is very simple. We have added the b square term on both the sides. Now we know that this whole thing will become now x minus 3 by 5 whole square is equal to 2 by 5 plus 9 by 25, which is equal to, we can now take LCM there. We multiply with 5 and 5. We will have 10 plus 9, 19 by 25. Let's go to the next step. We have x minus 3 by 5 whole square is equal to root 19 by 5 whole square. It is plus or minus. So can I write it as x minus 3 by 5 equal to, here I have plus or minus, I will have plus or minus root 19 by 5, which gives me that x equal to 3 by 5 plus or minus root 19 by 5, which is nothing but equal to 3 plus or minus root 19 by 5. So it can be 3 plus root 19 divided by 5, or it can be 3 minus root 19 divided by 5. So remember, whenever we have been given a quadratic equation in which a value is not equal to 1, please divide the quadratic equation throughout by a, so that you will make a as 1. Then your b is quotient of the x term divided by 2, and you add b square on both the sides, you will get it into the form of a minus b whole square or a plus b whole square. Then take the square root of that and get the value of x very easily. Let's try to do one more problem. Let's solve this problem. We have to find out the roots of 6x square minus 13x plus 6 equal to 0, which is a quadratic equation in standard form. So we will use completing the squares method, because that's what we are going through. So what is the first step to be done? I see that the quotient of x square is not 1. So I will immediately do divide by 6. So I will have x square minus 13x by 6 plus 6 by 6, which is equal to 1. So x square minus 13x by 6 plus 1 equal to 0. What we did is we just divided by 6, so that I can get a equal to quotient of x square term is equal to 1. Ax square plus bx plus c, where a equal to 1. Always a equal to 1. That's the way we are going to approach these problems. Okay, so the next step will be, now I have to find out b. I know that b equal to 13 by 6 divided by 2, that's equal to 13 by 12. So my equation will become x whole square minus 2 into x into 13 by 12, that is 2ab term, a square minus 2ab equal to minus 1. Now b square term is missing, so we will add b square term. So we will write it as x whole square minus 2 into x into 13 by 12, that is 2ab, plus b square, that is 13 by 12 whole square, is equal to minus 1 plus 13 by 12 whole square. Next step will be x minus 13 by 12 whole square is equal to, we have minus 1 plus 169 by 144, which is equal to 25 by 144, that is equal to 5 by 12 whole square. We will write it in the next step. So that is 25 by 144. Now let's take square root on both sides. If we take square root on both sides, we will have x minus 13 by 12 is equal to plus r minus 5 by 12. Therefore, x equal to 13 by 12 plus r minus 5 by 12. We'll get two values. The first value will be 13 by 12 plus 5 by 12, and the other value will be 13 by 12 minus 5 by 12. If you simplify this, this is 18 by 12, which is equal to 3 by 2, and the other value is 13 minus 5 is 8 by 12, which is 2 by 3. So the values of x are, roots of this quadratic equation are 3 by 2 and 2 by 3. So in the coming session, we'll try to understand what is quadratic formula and how to derive the quadratic formula. Then we'll do couple of examples solving the applications, word problems using quadratic formula. Then we will go into nature of roots and discriminant. So thanks for your time and support. Bye for now. I'll catch you again in the next session.